So far, we've seen how to build screens focus on the back office of the application. That is, the part that the travel agency employees use to enter and maintain the company's data. Now we'll see how to design and implement the screens that the agency's clients will use to browse the information, which constitute the customer-facing part of the application. The travel agency has requested a web screen for their clients that shows the available tourist attractions and allows them to interact with the information. For example, filtering the data on screen to refine a search or to see the details of a selected attraction. Previously, we saw how to build screens with web panels. Now, we'll see how to implement them with the panel object, which will allow us to generate the application in Angular. Remember that we could use these same panel objects to generate the screens of our mobile application for Android or Apple devices. We'll create the list of available attractions so that we can then click on one that interests us and see more information about that attraction. The idea is to build a panel similar to the WW Attractions from Scratch web panel that we saw earlier. We'll create a front-end Angular folder and create a panel type object named Attractions CF Panel. As we can see, here we also have a form where we can drag controls from the toolbar. We'll start by dragging a grid and selecting the attributes Attraction ID, Attraction Name, Country Name, and Attraction Photo. Then we set the visible property of Attraction ID to false. And in the base TRN property of the grid, we assign the attraction transaction. Now we'll assign Angular as a generator. In the KB Explorer, we click on Front End, and note that there's a property called Generate Angular, whose default value is false, so we set it to true. We also see that Generate Android and Generate Apple are by default set to true, but since we're not interested in generating for mobile devices at the moment, we set them to false. To be able to generate in Angular, we must install the software mentioned in the wiki article, which is shown on screen. To run it, first we set the panel we've just created as main. We right-click on it and select Run. We can see that a command line window opens showing the execution of the server. And after a few minutes, the browser opens with the application running. Obviously the design is quite poor, but we'll take care of that. The application is running by default on the URL http://localhost:4200, which is the address of the local development server, where the application was automatically installed. We already have our first Angular application running. If we go to the navigation list of the Attractions CF Panel panel object, we see that two entries are displayed. If we select the one with the panel name, the list is empty, and no reference to the attraction table is shown. This is in the node called Level Detail Grid 1, where we see that the information is similar to what we would see with a web panel with attraction base table, since the panel's grid is running through the attraction table to show the tourist attractions. The node in the list named Attractions CF Panel corresponds to the panel itself and includes information on user interface elements, such as the navigation of the dynamic combos. Since our panel doesn't have any elements in the fixed part, the list appears empty. The node called Level Detail Grid 1 corresponds to the grid we inserted. The attraction base table is run as we expected, after having inserted attraction attributes in the grid. The title of the report says that the navigation corresponds to the data provider Attractions CF Panel Level Detail Grid 1. which is the data provider published as a service in the backend and invoked by the panel to access the database and retrieve the attractions. Here's the evidence of what we saw before, that the architecture of these customer-facing applications with Angular has logic at the client level, and that services are invoked on the server to access the information in the database. To make our panel more similar to the Working with Attractions web panel that we've seen before, we'll add one more column to the grid, with the total trips of each attraction, and outside the grid, the total trips of all the attractions. We create the variables trips and total trips. We add trips to the grid by setting its label position property to none, and place total trips below the grid. To get the number of trips for an attraction, you have to run through the trip attraction table. As this is related to the database, we have to schedule an event to be triggered on the server. In the panel objects, we also have the start, refresh, and load events, like in the web panels. We'll schedule the events just like we did with the web panel WW Attractions from scratch. In the load event, we use a count formula that uses the trip date attribute to count the trip records. As we saw before, although the trip date attribute belongs to the trip table, Genexus will not choose the trip table as the base table of the formula, but the trip attraction table instead. As we know that the grid runs through the attraction table because we saw it in the navigation list, the load event will be triggered once for each row of the grid, so the count formula will count the trips of each attraction shown. Then, we accumulate in total trips the total of all trips. The same clarification we saw before can be made. In this case, we use the general load event because we have only one grid, but we could have used the grid1.load event, which allows us to add another grid to the panel in the future and not change the programming. Since we want the total trips to be initialized at 0 before starting to count the trips of the attractions, in the refresh event, we'll add the initialization to the total trips variable in a similar way to what we had done in the web panel. To run it again, we right-click on the panel and select Run. Looking at the navigation list, we see that there's a new level of detail different from the grid, called Level Detail. This is where the load of the fixed part of the panel is shown. In other words, all the controls of the form that are not included in a grid. Unlike web panels, in a panel object, the fixed part is independent of the grid, and, as we'll see later, the fixed part can even have a different base table than the grid base table. The navigation list of the Level Detail node, which invokes the data provider mentioned in the title, appears empty, because no field is being loaded from the database. There's only the total trips variable, which is updated within the load event. If we go to the navigation list of the Level Detail Grid 1, we see that the corresponding data provider is accessing the attraction table, ordered by attraction ID, that's the default order, and there's also the navigation of the count formula, since it's triggered in the load event. If we look at the application running in the browser, we see that the total number of trips of each attraction is displayed correctly, but the overall total number of trips comes out at 0. What do we do wrong? The total trips variable is being increased in the load event as we did in the web panel, and we're sure that this event is being triggered because we see that some attractions have trips. So, the reason is that panel objects don't work in the same way as web panels. In panel objects, the fixed part is loaded independently of the grid. In this case, the total trips variable is in the fixed part of the panel, which is the first thing to be loaded. Then the grid is loaded, so when the variable is displayed, the grid has not been loaded, the load event has not been triggered, and the value of total trips has not been added yet. Remember that in a panel object used to develop customer-facing applications, to load the screen in the client device, services located in the server are invoked, which are the ones that access the database. These services are data providers, which are independent for the fixed part and for the grid, or each grid of the screen. When the panel starts running, a local event is triggered on the client that invokes the data provider to load the fixed part and causes the start and refresh events to be triggered on the server. Then, a second data provider is executed, which triggers the load event on the server n times, and the grid is loaded. In our example, as the refresh is triggered first, the total trips variable is initialized, and the fixed part is loaded. Later, the load event is triggered, which is where total trips is loaded with the correct value, and the grid is updated, but the fixed part was already loaded before and is not redrawn. Due to this feature, we cannot program the panel object as if it were a web panel. In another video, we'll have a closer look at the triggering of events and the determination of base tables. For now, to make the example work, we'll change the programming. The solution is to include in the refresh event a for-each command that accesses the trip attraction table and counts the overall total number of trips. Let's not forget to remove the calculation we had in the load event. The reason why we include the update in the refresh event using a for-each command is because the refresh event will be triggered when the fixed part is loaded, which will be before the grid is loaded. Therefore, when loading the fixed part, the value of total trips will have the correct value, and only after that, the grid will be updated. We'll run it. Note that now the navigation list corresponding to the level detail node includes the for-each command with the navigation to the trip attraction table. In the browser, we see that the overall total number of trips is now displayed correctly. To complete the Work with Attractions panel, we would need to add the filters by the country identifier and by attraction names. We add, above the grid, a country ID variable as dynamic combo box. With the item descriptions property showing the country name, and set the empty item property to true. We also add the variables attraction name from and attraction name to filter the attractions by name. In a web panel, we would add the filter in the grid conditions, and here we can also do the same. Let's define a condition to filter by country, and others to filter from and to the name of the attraction. We also have an order property, where we're going to set the grid to be ordered by attraction name. So, we right-click on Orders, give it a name, for example, Name, and then right-click again to open the attraction name attribute. We can define an order by several attributes, as well as create other orders by different criteria. The part where it reads Break By allows us to group the grid records. For example, if we want the attractions to be grouped by country name. If we right-click on the panel and select View Navigation, in the navigation list of the panel itself, we see that the country table is accessed to fill the dynamic combo box, where it says Fill Country ID with Country ID, Country Name in. The navigation list of the level detail node shows the data provider report, automatically created by Genexus, but not displayed in the KB. That's invoked on the server to retrieve the data from the database, which is necessary to load the fixed part of the panel. This data provider triggers the start and refresh events on the server. In the list, we see the for-each command that we programmed in the refresh event, and that accesses the trip attraction table to count the total number of trips. Also, we see the access to the country table filtered by the country ID selected in the dynamic combo. If we look at the navigation list corresponding to the data provider that loads the grid, we see that now the attractions will be run through in order by attraction name, and that the constraints show the filters that we defined. This data provider executes the load event internally, once for each line of the grid to be loaded, as in web panels, if the grid has a base table, and returns the information to the panel to be displayed. Something we mentioned was that the fixed part of the panel is loaded independently from the loading of the grid. Different data providers are invoked that are published in the server as services and access the database to retrieve the information of each part. When we change the value of a filter, the grid information needs to be refreshed. For this, we need to add the grid's refresh method, which will trigger the server's refresh and load events. In turn, it'll cause the grid to be reloaded, applying the programmed conditions and displaying the filtered results as expected. Since the grid's refresh method must be invoked after we change the value of the filter variable, we use the control value changed event of each variable to invoke the method. In this way, after changing a value, when leaving the field, the corresponding event will be triggered, which will end up refreshing the content of the grid. However, there's something else we need to take into account, which is that in this architecture, since the objective is to have the page loaded as few times as possible, the data cache is prioritized. That is to say, we always try to retrieve the information previously saved. For the server to understand that we want to bring new data, the URL sent to the server must be changed, so that it understands that it's a new page and obtains the corresponding information from the database to send to the client. To do so, we added a parm rule containing the values of the variables used in the filters. In this way, if a variable's value changes, the page is updated with the new data. Now we'll run it to test what we've seen. Note that at the top, we now have the filters we added, and the attractions are sorted by name as we expected. We'll filter by the country China and see that China's attractions will be displayed. Now we choose to see the attractions that begin with the letter A to the letter N, and we only see the attractions in China whose name is in that range. Now let's complete the agency's request, which is to show the details of each listed attraction by clicking on them. For this, we'll use another panel object named Attraction Detail CF Panel. To save time, I've already created it. We see that in the rules, we define a parm rule with an input parameter, the attraction ID attribute. Remember that this will allow showing only the information of the attraction passed by parameter, which was the one we selected in the panel of the attractions list. In the form, we added the attribute attraction photo and the attributes attraction name, city name, and country name. Below, we inserted the attraction description attribute. Next, we inserted a grid and selected the attributes attractions info name, attractions info image, and attraction info description to see the attraction details. As we can see, we've inserted some table controls for better alignment. We also added a back button at the top right corner that will invoke a return that will allow us to return to the list of attractions. Now we go to the panel Attractions CF Panel and add a detail variable of character type to the grid. In the start event, we assign the text details. Next, we insert an event on the detail variable of the grid. Select Tap and write the invocation to Attraction Detail CF Panel, passing Attraction ID as a parameter. Let's try this at runtime. we'll see the information of the Louvre Museum, so in the corresponding line, we click on Details. The panel opens with the attraction's details, where we can see a map and the available exhibitions. At the beginning of this video, we said that if we wanted to, we could use the panel objects we built to generate the screens for our mobile application. Let's try this out. In the KB Explorer, we click on the front-end node and set the Generate Android property to True. And now, we execute the main object, Attractions CF Panel. We can see that the Android emulator opens, showing the Attractions CF panel with the list of tourist attractions. Obviously, we should define a layout according to the screen size of a phone, since, when we designed the panel, we were thinking about the screen of a web system that would run on the screen of a desktop computer. But beyond the design, let's check if it works properly. In the filter, we chose France, and it shows only the attractions of France. Now we click on the details of the Louvre and see that the screen opens with the details of the museum, showing the map and the exhibits as we expected. In this video, we started to get familiar with the panel objects, generating the application in the Angular framework. We confirmed that with the same objects created, we could also generate the application in native Android language. Next, we'll learn more about the event management at client and server level.